So hello everyone. I'm Karim Naji. I work on the GL JS team. And previously I've worked on the Tangram renderer, which is previously I've worked on the Tangram renderer, an open source mapping library from Mapzen that's now owned by the Linux Foundation. And a few of my side projects is this photorealistic map renderer where you can select a geolocation on the world and have a full lighting solution cast onto some 3D models. And I've also worked on other things such as this. So that's the kind of render that you can get from this tool. And the other thing that I worked is a project called Vectiler, where you can also take any geolocation on the world and export 3D models that you can use then in Unreal Engine, Blender, and all those sorts of new advanced rendering tools that are not dynamic maps. So today I'm going to be talking about Mapbox GL JS, and a little bit about the background for this is it's a library for web and mobile, and on the web it's targeting WebGL, and on native we target OpenGL ES2 and also Metal. And it's a vector tile based rendering, so it takes packets of geographic data that's usually in WebMarketer, and then we transfer that over the network, and it gives us a really advanced flexibility for styling at runtime. So this library comes up with a lot of nice styling that our designers have made that you can use out of the box, but you can also go pretty deep and use your own styling expressions and filtering on Mapbox Studio, which is our editor. So the relationship between Mapbox GL and deck.gl is that Mapbox GL is just one of the numerous rendering backend that deck.gl has. And it's doing it so with the flexible custom layer implementation that we have that I'll talk in more detail later in this talk. But basically, this layer allows you to do any sort of rendering with custom graphics API, such as WebGL, and it gives the power of developer to use their own shaders and use their own rendering stack if needed. So that's how deck.gl achieves things such as the shadows, the arcs, and all of sort of thing that you can draw on top of our maps. So today I'm going to be talking about V2 and the new things that we added, such as projections, globe view, terrain, and other sort of improvements that are nice quality of life improvement. And then I'm going to be going in more detail of third-party rendering with custom layer and runtime elevation querying. So let's dive into the first thing, which is adaptive projection. So a lot of interactive maps nowadays were primarily used for street level navigation. So using WebMarketer, which preserves angles between lines and also makes it so that north always points up. But at the same time, it heavily distorts the sizes of things at global scale. So inflating shapes that are further away from the equator. So it makes Greenland appear a lot bigger than Africa, even though it's like 14 times smaller. So it makes our perception of the world a lot different from what it actually is. And so with these issues in mind, we wanted to have Mapbox GL allow users to use any kind of projection to be able to use it on the fly without any changes on the data on the server. So we call them adaptive projection because it does the best of both worlds. It uses the street level, it preserves the street level Mercator properties. So when you really zoomed in, it transitions smoothly to Mercator, and on the low zoom level, it uses the projection that you can choose. And the API surface is really low, so we tried really to make it as simple as possible for the user, where you just give the name of the projection, and that's all you need. The styles are all working, all the layers are keep working, and there's no other changes that you need to do. And you can see here, changing on the fly on Mapbox Studio, where the data is reprojected from WebMarketer, which is the format where our MVT tiles are, and then using the projection at runtime, using Albers in this case. And one of the projections that we introduced as well later this year is Globe, which is the only true 3D projection that we have. And it's the one that gives a really true sense of depth in the scene compared to those other projections that were mainly 2D on a flat plane. And similarly, it's very easy to set up. You just give the name of the projection, Globe, and everything works out of the box. There are still a few public API that we are working on, but that's the sort of effect that you can get. And similarly, we transitioned to Mercator on the very high zoom level, just for rendering quality, because Globe uses draping, a draping technique that we also use for terrain. And we want to leverage draping only on low zoom levels, because that's introducing sometimes some texture artifacts, and use vector-based rendering on high zoom level. Some key points about Globe View: it uses the render cache that we also have with terrain, and it only re-renders things that aren't changing, so that you capture a texture once and you reuse it a lot of times, so that you don't have a lot of redrawing. Like I said, all layers are supported: heat maps, video, all of the layers that we currently support. All camera animations are also working out of the box, and all UI interaction have been revised to feel really smooth with the Globe. So that's an old example that we took and just enabled, where you can see the animation tracking both on the Vendée Globe. Or some more funky example with fill extrusions directly on top of it, where we create sometimes more vertices to be able to perfectly match the surface of the globe dynamically. So if the polygon doesn't have enough subdivision, we just create more of them so that they can be extruded and feel like they are part of it. So the next thing that we've added in V2 is also terrain, which is similar to Globe, using the draping technique, where we take a 2D texture for each tile and capture all the layers that are contained within that tile, and then get a DEM data for this, and then extrude it on the fly. So it has downsides. Draping is not the best technique, but it's fairly fast to render on the client. And it's a little bit more involved to create terrain on Mapbox, but the only thing that you add is a source for the DEM data. And then you can use both Mapzen terrarium tiles, but also the DEM format from Mapbox. And then you enabled it by setting the terrain, and eventually an exaggeration where the default is 1, which is the true realistic size of the terrain. And then if you want to have more visuals, you can give more exaggeration to it. And we also improved 3D symbol placement with terrain, where you can have dynamic expressions based on the distance or the pitch. And this can be motivated for performance reasons, where you want to reduce the clutter at the distance and only have labels showing closer to the viewer, but also if you want to, for example, show lead lines here, where you extrude only when the pitch is higher than a certain degree. And here is an example of such expressions. It can feel pretty daunting, but it's basically like a conditional statement on the pitch, where below 60, it's just showing the label. And then when it's over 60, you just get the distance from the center, which is an arbitrary unit here. But then it says that when it's over 60 and the distance is close enough, then you can render those labels. Otherwise, you just hide them. And then you apply the filter to the layer like so. Another interesting thing for distance-based styling is the fog and atmosphere. And it's a fairly similar thing, where you want sometimes to reduce the clutter at the distance and recenter the viewer, recenter the attention closer to the viewer, but also eventually cut tiles at the distance for very, very pitched views, which can be useful sometimes in navigation. So this can have both a visual impact, but also a high performance impact. And here is how it looks with the globe on low zoom level, where you can go slightly realistic with satellite views, but also more stylistic with vector style data. Some interesting things were also improvements to transparency, where a lot of users were complaining about the transparency having a lot of overlaps with self-intersecting geometry, and we are now using a stencil-based technique to have consistent opacity throughout the entire line. And yeah, the next thing that I'll talk about is third-party rendering, which is closely related to deck.gl integration and helpful for developers that know a little bit more about WebGL and how to develop shaders and their own rendering stacks. So custom layers are just a specific kind of layer that allow a user to render directly into the context, the rendering context. And for those of you who are familiar with 3D rendering, one way to describe how a renderer displays a scene is taking a lot of objects and then projecting into a 2D image, which is why we often have this matrix here that helps do that for the user. And in the case of maps, the data is just the layers, or it can be points, it can be particles, it can be a lot of different things. And the API also has options whether you want occlusion to be enabled with 3D and the depth, which is how deck.gl achieves the interleaved versus the overlaid option, but you can have also everything overlaid on top. And pre-render here is an optional method in case you wanted to do some off-screen rendering or prepare some textures and do whole sorts of pre-pass rendering. And with terrain and draping, we added 2 new methods, which here is rendering to, it's related to the render cache. So it tells whether a texture needs to be re-rendered in case you had any changes in the tile. And this one is when the tile is actually rendered. And in this case, it doesn't have a projection matrix because it's the entire viewport is aligned with each tile. So you can just draw all of the pixels for it. And then you issue the rendering. And this is the kind of example that we took from prior to having Globe, and with this new interface, the kind of visualization that you can do. The other interesting thing that we added is runtime client-side elevation queries, where you can query to an elevation without any server access. So you can, as we reuse basically the DM data that's used for terrain in a way that is fairly efficient, because you query the DM data directly from the terrain rendering side. So it's what you see is what you get type of interface. So as long as terrain is loaded and you view it, you can you can make a lot of querying of elevation data. So you could have, for example, a mouse over and query what elevation is at a specific coordinate. But that's also useful in the custom layer interface in case you wanted to elevate models. So for example, a tower on top of terrain, you can inject this elevation at the z-axis unit. So here the x and y are the Mercator x and y, and then here you give the elevation in meter with eventually a scaling factor in case you had also the exaggeration. And what's next for GLJS is finalizing full API support for Globe. And we're hoping for more collaboration with deck.gl for the V2 integration. And we're also working on better styling for 3D with built-in styles, and eventually better lighting model, because 3D can look pretty flat without lighting. And then we're always chasing 2D performance, so there are a lot of new things coming out for that as well. So thank you a lot for listening. In case you have any question or want to reach out, here's my email and the repository for Mapbox GL in case you want to have more interactions with us. And we're really hoping for more collaboration in the future. So hoping to collaborate more.
I have a question that is more related with the idea of integrating the version 2 with deck.gl. And right now in Deck, we have like two ways of integrating Mapbox GL. One is with the interleave mode, with the module that we have for Mapbox GL. Is that something that you have in mind to continue collaborating on the integration on that module for this version 2 and so on, or is on the other way?
So yeah, I'm not sure I fully understand the question with the interleave mode.
Yeah, basically we have now two options to integrate Mapbox GL inside of Deck. One is using the React module for Mapbox, the module in Deck of Mapbox GL, and it's allow the user to use things like, for example, interleaving and so on, but it's still in beta. And I think that would be great if we have that inside of deck.gl, because it's allowed to create different kind of visualization, or you can interleave different layers and so on. You can share the same canvas and stuff like that. Just asking if your collaboration in deck.gl between Mapbox and so on is going to be on that direction or on the other way.
No, I think it would be nice if we can keep those together and in sync over time, and not break things through our APIs, because I know sometimes you use private methods and things like that, and we would like to expose as much of them if possible.
That's great. Thank you.
Does the custom layer API right now support all the different projection modes?
Not yet. And that's things that we would like to have if that's possible.
So something I'm gonna complain about is so in the render method that the custom API, custom layer API is supposed to implement, the matrix you're passing to us is the view projection matrix. It doesn't tell us how we can transform the lat-long coordinates to the common space, right, to the Cartesian space. And this is not an issue in WebMarketer because we know how WebMarketer works. But for all the other projection modes, including globe, you have this switch from whatever custom projection to WebMarketer when you zoom in enough. And that is, to my knowledge, nowhere exposed in that API. So how do we know how we can transform our coordinates to correctly work with that matrix?
So these are all internal still. But if there is anything that could be helpful for projecting and doing custom layer integration with projection and globe, I think we could expose those things. But right now, all those projections, they are pretty deep into the code base, so there's no exposure of that. For terrain, this is the only way you can do it, because terrain is still terrain is fully integrated with the custom layer interface, but not yet with projections.
All right, so we don't have sufficient API support.
Not yet, no. But I'd be happy to hear what would be helpful in that sense.
Yeah, it'd be great if we could have some sort of operational channel of communication. Yeah, with the
Any other questions?
So thank you. Just so that I also understand it. So because of that technology right now, like we wouldn't be able to overlay a deck.gl layer or something like this 3D terrain type of visualizations, right?
So right now in the deck.gl integration module for Mapbox, we have limited support for terrain, as in we will, I think as of the latest alpha, we can correctly match the camera, because Mapbox messes with the camera when you are panning over terrain. And I have an open issue on your GitHub and end up having to like hack the projection matrix a lot. But we don't really have a way to drape over the Mapbox terrain. And if there's documentation on how Mapbox wants that done, I'll be interested to see it.
Yes, so the draping is in progress, but the projections that are messed up that can be something to follow up on for sure. Because the center is always dynamically moved with the terrain, so that can also really mess up the upward implementation for sure.
Thank you very much.